I'm ready.
Oh, I didn't even do that. Hang on, we had one other person that just came in. This meeting is being recorded. Did you start that, Bobby?
Yes, that was me.
Guilty as charged. Okay, folks, so for the very first time, we have 9 people that are attending in person at the classroom and everybody else is on Zoom. So it's fun to see everybody here. This hybrid meeting is our first attempt to ever do this. So we're really excited because I'm a very old person and I can't remember faces on Zoom very well. This is going to help me a lot. I wore my name tag for the first time, so you'll know who I am. The guest speaker that we have today, I'll introduce him real briefly, then he can talk more about himself. Is a friend of mine that lives in Livingston. He's in the Piney Wood Lakes Master Naturalist chapter. And so I met him through the Lake Livingston Conservation Project that I do my volunteer work in. Ron is part of the leadership team for that, and he predates me. I started that when I was an intern with Heartwood in 2017. He was, you can correct me if I'm wrong, Ron, but I think you were originally there with 2013 when the project started up.
Not quite. I was about 2 months into the project.
Okay, and so, but he's one of the founding godfathers, if you will. So we've worked together for a long time and have fun on the Lake Livingston project. So it's one of the things we like to do. And because that's a bit of a hybrid project, we have some members from Heartwood that are in that project, and the rest, most of the members are at Piney Wood Lakes. We get to meet another chapter and interact with them, and it's a lot of fun. So with that introduction to Ron, you can tell them more about your background. I can tell them you're a certified CPA, and I can tell them you're an oceanographer and be right on both counts.
I'm a certified public accountant.
And I'm going to turn.
I'm going to spotlight me.
All right, so can everybody hear him good? All right, Ron, you've got control. You can share your screen. We're going to do 2 parts today. Let me just clarify that. Ron has helped me out both at the Ellis unit when we do this master naturalist training at the prison that's up northeast of Huntsville. And he's done it at Ellis unit many times. He's never done this for Heartwood, but one of his interest areas is waters. He's going to give you really everything you want to know about waters, but we're afraid to ask. And it's going to be followed up by something I think that you'll be interested in. For the first time ever, we have a guest speaker that lives in the Woodlands that's involved in water issues in Montgomery County. Montgomery County's got a lot of water issues. It's under political debate. It's under scientific discussion. Neil is going to join us after we take a break and after Ron finishes. So I think Ron's going to set the stage for Neil to kick things off for the balance of the session this morning. So with that, I'll turn it over to you, Ron.
Over there, I could be tossing this around the room like they do at ballparks. We use this to when we teach kids about water. Elementary kids, we've done quite a few classes over the years that I've done trying to deal with water issues with the primarily grade school kids, once in a while with high school, but mostly grade school. And this little exercise here, they would toss the beach ball to each other and they would catch it. And then they would look to see where their index finger was pointing. And we keep track of whether it was pointing to water or pointing to land. It's a good exercise for young kids because they don't have to sit still. They can bounce around. And then you say, well, what could possibly go wrong? I just said what could possibly go wrong. Number one is they have a heck of a time catching the ball. They can't seem to get their eye-hand coordination right to go ahead and catch it. And the ball goes bouncing around like the bleachers at the ballpark and never lands in one set of hands to count it. So this exercise turned out to be really difficult because simply they wouldn't do it. And pretty soon there was lots of laughing and giggling and the ball flying all over the place and hitting the ceiling fan. And you learn a lot when you deal with these kids. One of the things that that I did is I took a glass jar of water from Lake Livingston and held it up and asked them if they would be willing to drink that water. knowing that the majority of them were drinking the water, that Livingston provides over half of the water for Houston and almost all of the water for Livingston. So it was, telling them that they were already drinking it was a bit of a surprise to the youngsters. What was interesting to me is that every single class, without fail, had one class member say that they would not drink the water, and the reason was fish poop, which I thought was fairly interesting. The classroom technique that seems to work consistently is where we take the tube, the clear plastic tube that's about 5 feet tall, and it has a Secchi disc in the bottom of it, and we add water a little at a time and have them keep checking until they can't see it anymore, and then we show what the visibility is. I've tried to take it further and explain the difference between suspended solids, which is what you see when you're looking at visibility, and dissolved solids, like what would be if we put sugar in the water or salt in the water and dissolved it. It wouldn't, you wouldn't be able to tell unless you tasted it. But for the most part, the elementary kids, I started losing them at that point in time, but they understand visibility and they love doing the experiment to find what the visibility is. We have used, the state park has the kits, the water testing kits. And we've tried to use that, but that's definitely high school age. The youngsters, they can test for the dissolved oxygen and actually come up with fairly decent results. The problem is when you explain to them why you would test for dissolved oxygen, you lose them. They have a hard time understanding that both the plants and the animals in the water depend upon the level of dissolved oxygen. And if the level is low enough, they die. If it's intermediate, they can't reproduce. And of course, if it's over 4 or 5, then it's okay. So these concepts are difficult. With the young kids, you've got to keep it pretty light and going forward. With that, I'm going to go ahead and start the slides. Let me share a screen here and go to my slides. Okay, where slideshow? It's covered up by the drop down.
Looks like your recording is fine.
Started the presentation here with a number of books that we have in our library, just as a sample of some of the things that are available. This is something from TCEQ. Can everybody see this okay? Is everything working?
Yes.
Okay, this is from TCEQ, and it's a lot of the TCEQ books are available in PDF format, or in many cases, they'll send you hard copies. They have a fairly extensive library of things that you can get under the water section publications. This one here talks about doing water education and things that you can do to do water education, which fits our purpose pretty well, because we try to get out and share knowledge as we get it with the people around us. This one here is from the darn, if I could get rid of this stupid thing at the top, I can't see the top of my slides. It's from the Sierra Club, and it's a pretty good little book which has all kinds of facts about Texas water. It's pretty easy to read and go. It's also bilingual if that matters. This one here is from Parks and Wildlife and has some beautiful pictures in it. although it's less technical than some of the other ones. This one here is something that you may have available from your chapter, and Scott says he'd go ahead and talk about the Texas Waters program and the availability of this book for you all in your chapter. Scott? Hello, Scott.
He stepped out.
I told him he was right at the beginning.
Oh, that's Scott.
Okay, who else is in Texas Waters over there?
Terry?
Yeah, but Terry can't talk because her mic's not working.
Oh my gosh. She says T-Mac has some of these on her in the chat.
Okay, so
Oh. Hang on. Let me get to
Texas Waters is a sub certification within the Texas Master Naturalists. Scott was one of the very first people that became certified under this program. When you log your hours, your advanced training hours, at least in our chapter, we have a checkbox where we can check that it applies to Texas Waters. Hey, Scott, you want to go and handle Texas Waters here?
Why did you choose the only time I wanted to go to the restroom? So,
You're an old man, you go every 10 minutes. I didn't know.
yeah, thank you for that support. So long story short, the guy named, tell me if I'm repeating myself, Ron, Johnny Smith is the guy with Texas Parks and Wildlife that actually organized and led this. He was, I think he led his title was something to do with Education Committee at Texas Parks and Wildlife. This Texas Waters program is new, but it's voluntary and it's supplemental to what you're getting with Master Naturalist Education. So all the chapters that are in there have challenge questions at the start. It's a self-study curriculum, and that self-study curriculum means that you read through it. In theory, you're supposed to get together with several people like in the chapter or a group, and you get together and discuss each chapter and sort of what the stuff that you saw out of it. At the end of it, and while you're going along, you can get training credits for this, like advanced training, but it's self-study. There's a whole lot of projects that are designated as certified Texas water specialist, and you'll see it on the drop-down list. Like if you chose some of the stuff that Terry MacArthur does for her volunteer hours for watersheds or the stuff she's doing in the woodlands, you can check that box and those count toward volunteer hours for this certification, but they also count for your volunteer hours for Heartwood. So at the end of it, you get, how many hours is it, Ron? 10?
You know, I'm not even sure.
Yeah, I'm not either because it's been so long. Asked me to unmute you. Yeah, Terry's microphone's still not working, so we can't get her to chip in. But if I've got this right, this 10 hours of certification, and it will correct that if it's wrong, gives you a little pin, just sort of like a separate pin that you would get from the state for your Master Naturalist certification. The Lake Livingston project that Ron and I are involved in, that qualifies as Texas Water Specialist. So all the hours that I claim for that, I just check that little box and it goes to the state. And there's a girl named Melissa Alderson that keeps track of that. If you've heard of the TMN Tuesdays, she also does a monthly presentation that count toward the hours that you get for this certification. And you can find that this book is free. So if we can't give it to you from the chapter, we can get it from the state and you can get it for free. And we do this at the prison unit also, where instead of, unlike you, where we have discussions about the water issues, we make the guys answer those challenge questions so that we believe that they get a full comprehension of what's in the book. They also get a certificate, which you don't get. You're going to get a pin. And so anyway, that's probably enough of that, right, Ron? Oh, wait.
The book is very good and expands.
Hang on, Ron. Ron, hang on. Go ahead.
The book that you're speaking about, is it the Texas Waters or?
No, it's that one.
Okay. Texas Parks and Wildlife?
Yes.
Okay.
And I think at one time we brought back at one of the annual conferences, they were giving away cases of those books and we'd sit them on the shelf here and people would get them. I'll check with Carolyn in a minute and see if she can either order some more or if you need to just send off for one. but
I
it's,
have some, oh, sorry, Scott. I have
Go
some
ahead.
information that Terry added. She says that it is 8 hours of training, then recertification is 10 hours of volunteer time. She would love to have some training sessions for the TWS certification, and all of the programs she offers are approved by Melissa Alderson. She also has a box full of these manuals.
and you're sending Terry's notes out for the meetings monthly, right?
Yes.
Okay, so that you as part of the chapter, you're going to get notification when she does have a meeting. You can attend that. Terry's got a full box of them, so you can get them there if you'd like. I just saw the chat too, Carolyn. Thank you.
You are welcome.
Yeah, and just to reiterate, it's 8 hours of training and 10 hours of volunteer time. Now remember that the training can count toward advanced training, separate from this, and the volunteer hours can count toward your volunteer hours for certification. So you can double dip on this one. Okay, Ron, go for it.
Okay, the next topic that I wanted to quick cover was the stream team topic. I'd gone online to get an update on the reporting, because there's a whole lot of reporting stations in Harris and Montgomery County. But Terry says that the data hasn't been uploaded in over a year because the Houston GAC, HGAC is not having office hours, so they vet the data before it's uploaded. So as a consequence, there hasn't been much information uploaded. In any case, this is a volunteer program where somebody goes to a specific waterway or a point in a waterway, and they do ongoing testing of the water there and reporting it as a citizen science project. If there are any questions, Terry would be the one to answer them. The kit to do the testing is quite expensive. So it's not like Coco Ross where you can spend 25 bucks and get the testing. This is a $400 and something test kit, as I recall. Let me finally do my introduction. I moved up to Lake Livingston and bought a lot on the shore and started building a house 22 years ago. And while I was commuting into Houston, I didn't have much time to do anything other than work on the house and work on the job. But once I retired in 2012, I had time, and by that time I had a porch that I could sit on, and I was looking out over the lake. And I said, you know, I know absolutely nothing about that lake. I don't know what's in the lake. I don't know the history of the lake. I don't know the impact of the lake or what the issues are related to the politics of the lake. You know, it was just a long list. In fact, as I wrote it down, and I had 2 pages of notes of things that I didn't know. So I decided that I wanted to go ahead and start learning more about the lake. About the same time, there was a article in the local paper talking about a startup group under the master naturalists that was going to start putting native vegetation into the lake in order to improve habitat. I thought, well, that'd be a good place to start. So I called up the director of that project at the time and asked him, what should I do? And he says, well, go through the master naturalist training is step number 1. It's starting up right away, so you can get right in and do it. And then we'll have plenty of things for you to do. At that particular time, a lot of the work was being done to organize the project. The plants, the water willows that we were putting in the lake, if you buy them at commercial nurseries online, retail, they're $7 a piece. And they told us that we were going to need at least 100,000 of them. So we said, oh, wow, that's in Polk County. That's a too tall a mountain to climb to get that kind of money. But we found that what we could do is propagate our own plants. We could buy some plants wholesale at $4 a piece. And then we could propagate the plants in nurseries, which are basically a tank of water. And we could put these tanks at the high schools, and we could get the high school kids not only to propagate the plants, but to help us with the planting. And the project took off from there. I'll talk a little bit more about it at the end, and Scott is the head of that project, so he can answer a lot of questions as well. But I love this quote from Aristotle, and that is, once I started digging into this stuff, I found out that the more I know I don't know. And that's proven to be the case as I get deeper and deeper digging into answering the questions about waters in Texas. I keep finding out that my list of questions, instead of being 2 pages long, is 30 pages long and growing. What I'm doing today is I'm going to include some of the things that I've found, and maybe some of the more challenging thoughts than what you find in the matter-of-fact statements in the textbooks. Some of the stuff is a little bit less black and white than what it appears when you read a fairly basic textbook on the topic. So moving on, the first thing I'm going to do here is I've got a little video, if I can make it work. It's interesting. This is the diagram that you find on textbooks all over the place, on the textbooks, on the web. This diagram is absolutely everywhere, and it lays out where the water is. What's interesting is, if you look at it was done by a Russian, by the way, Igor Shikomanov. I probably blew that. In any case, it was done in 1993, and it's been referenced over and over and over again for the last, 30, going on 30 years. And it's not changed in those 30 years, and yet we all know that there has been some melting of glaciers and ice caps. We know that the permafrost and the ground ice has been affected by global warming, but this does still give an overview. If you look at it, the oceans represent just under 97% of the water on Earth. And if you include the other saline water from the salt lakes, it's is over 97%. Freshwater represents only 2.5%. Of that 2.5%, over 2/3 of it is tied up in ice. Almost 1/3 of it is in groundwater, and there's just 1.2% of the 2.5%. So 1.2% of 2.5%, we're starting to get a few decimal places out. Is surface and other freshwater. Of the other freshwater, you've got 70% of it is tied up in ice, or was in 1993, and lakes represent 21%. So 21% of 1.2% of 2.5% is what we're dealing with in the lakes. The rivers are a fraction of that. you look at this and you say, oh, wow, on the news all this week, they've been talking about Lake Mead, and they've been talking about shortage of water and the shortage of water worldwide. And you look at it and you say, well, how can there be a shortage of water when the water that we're using is such a small fraction of the total amount of water? Historically, people, going back to nomads, people set up their villages and eventually cities and buildings near water. Water was something that was a requirement, and they located near water all around the world. When they were nomads, if the climate changed and the water moved somewhere else, they moved with it. Now we've got so much infrastructure built up around the location of water. When the water moves to a new location, we struggle. The other thing is I've got a book reference a little later here. Everybody thinks that water is free, and the charges that you pay for water are for transporting the water from where it exists to where you're going to use it. And in recent decades, purifying the water or treating the water so that it's potable. This is it's really interesting when you take a look at the water. The problem is the water isn't either in the right place, or it's salty, or it's polluted. The available water. So when you eliminate the salty water and the polluted water and the water that's in the wrong place, you end up with a tiny fraction of the total water that's available that's actually being used by everybody. It's interesting to me that this is not something that's being tracked all that well. The fact that we're using a 30-year-old document that was somewhat supported in its day is there's a fair amount of assumptions and hypotheses in this. This is only really good for an overview. It's not really good for any kind of planning, I guess. Here's an interesting thing. Most of the textbooks will tell you that the water that we drink today is Tyrannosaurus Rex P from a long time ago. That the amount of water, the total amount of water that's on Earth is fixed. It's not changing. All that's happening is we're recycling it over and over again, either via the water cycle or by, and these days, man-made activities. That's not really true. And the total amount of water is changing. It's interesting when they look at at why we have the water that we do on Earth. The common theory is that it came in via asteroids striking the surface of the Earth. That actually came that way. And scientists are now thinking that that's not really the case. For those of you that are more biblically oriented, it's noteworthy that the Bible doesn't say that God created the water. The water was already there when he started creating things when it describes creation. So the actual origin of water has been a mystery both scientifically and religiously. More recently, one thing that's been discovered is there's a lot of this stuff in the Earth's mantle. The OH and which is hydrogen monoxide and free hydrogen. And they're separated under a lot of heat and pressure because we're looking at something that's at least 25 miles down in the mantle. And it's there under high pressure and high heat. And what's happened is as the Earth mantle moves, if you all have had your geology stuff, when the Earth's mantle moves, some of this stuff gets released and water is actually being increased over time because of the recombination of the OH and the H when it's allowed to come up to the surface. And of course, those of you that are chemists know that if you burn hydrogen, you create water as well. And we're creating hydrogen from fossil fuels, and we're using it as a fuel and producing water that way. But all of these amounts are relatively small and do not have a whole lot of impact on the total water. In order to deal with water resources, you have to look in other directions. Here's the book that I love this book. It has a lot of challenging thoughts in it. I highly recommend it. It talks about water and water resources in general. And then it talks about a lot of specific cases where people have, in some cases where entire towns have totally run out of water and had to deal with it and had to come up with a solution. Or in other cases like Las Vegas, where it was clear that they weren't going to be able to sustain their growth without having a source of water other than Lake Mead. Or in Australia, in Adelaide, I believe it was Adelaide, where they were running out of water rapidly in Australia and they had to deal with it, and in Perth on the western coast. And it talks about the various solutions that places that were running out of water came up with and what the success was. It's a very good book if you're interested in water being the new gold. This book also talks about the concept of our stupid view that water is free and that we don't need to do anything to conserve it or anything. It's always there. There's so much of it out there that we don't need to worry about it. Well, we do need to worry about it, but we need to worry about it because it ain't in the right place. This book, this is a concept. There are hundreds of versions of this where it talks about the water cycle. And this one I like because it has the terms that you need when you're looking at the water cycle. Evaporation of water from bodies of water from this would be the ocean and this would be a lake or a river. It talks about condensation, which would be in the clouds, which would result in precipitation, which leads back down to the water. It talks about transpiration, which comes from the trees and land and also from animals. That goes back up into the clouds and comes back in precipitation. It talks about infiltration going down into the water table and the water table moving to the surface water over time. What it doesn't show is there's also movement from the surface water to the water table if you've got what's called a losing stream, for example. So this has a whole lot of the terms. What this doesn't do is give you a feel for the relative importance of these elements. In other words, what's more important, evaporation or transpiration to the water cycle? And there are a lot of, or not a lot of, but there are some articles or videos that I've come across that talk about the difference of transpiration if you have concrete, the difference of surface runoff if you have concrete, the effect of trees in the overall issue of water resources. But it's difficult to come up with actual data. And part of the reason for that is the data is pretty site specific. It varies depending upon what geographic part of the ecology you're looking at. If we look at Texas, I found this interesting deal. And it shows that we're talking about acre feet per year. And I've got a illustration of acre, well, I'll go to it. 1/2 acre yard plus 1 inch of rain equals how many gallons of water? Anybody want to guess? I put you to sleep already. It's terrible. There's some mathematicians out there. Okay. Answer. 1 inch of rain in a half-acre yard is 13,577 gallons. That's enough to flush a lot of toilets, to say the least. There's a whole lot of water that's coming down in the rain. And if I take a look at the data again, you know, the precipitation over all of Texas in a year, this is acre feet per year, is 379 million acre feet per year comes down via rain. But 320 million of that goes back via evapotranspiration or transpiration. And 7 million of it goes back up because of evaporation from bodies of water, which means that if you look at it, the 35 million eventually runs off to the Texas coast. 9 million goes off to other states, and 5 million goes down into the groundwater. Although 1.3 million of that is returned from the groundwater back to the surface water via the base flow. So what this tells you is that the evapotranspiration in Texas, basically the water cycle is short-circuited, and it goes down to the surface and back up into the clouds almost right away. It's the whole water cycle is not that long one that you look at. Earlier, I was talking about activities that we do with kids. One of the activities is to play a game similar to musical chairs, where each chair represents a type of water. Frozen water, ice, ocean, lakes, rivers, clouds. And we have them basically sit in the chair until they roll a number. And if it's ice, you know, they might have to roll a 666 in order to leave the chair and go to the next chair, which means you stay there a long time. Where if it's trees, they can roll any number and move on to the next chair. And we try to teach them a little bit about the water cycle, the components of the water cycle, and some of the elements that are explained in this diagram here. The next question I have, and I may sit and make somebody answer these because it's kind of interesting, I think. This question is these are kind of difficult. Who owns the water in Texas? I'm gonna wait for an answer. Somebody better unmute or
There's 10 people here that haven't answered yet.
The state.
The state, one person says the state.
that's actually close.
President Textbook said the surface water is owned by the state and the groundwater is owned by whoever owns the land.
Did you hear that?
No,
Surface water is owned by the state. The groundwater is owned by the residents.
Yes.
the correct answer is the water is owned by the people. It's controlled.
We have a winner for the in-person participants.
The control of the surface water is via the state, or the state has designated the control to other entities in many cases. But ultimately, the control legally is with the state ultimately. Groundwater is owned by the property owner. Under Texas law, the water that's underneath your feet is owned by you and is not owned by the state. It is owned by the people, but in this case, only the people that live on top of it in that specific spot. And I can talk a little bit more about those laws in a minute. Actually, I'll do that when we get to the groundwater section. And also the river authorities section. Next question. Okay, we know who owns the water. Who owns the land beneath the water?
Well, that's a crappy question. Any guess?
You know, where it matters is if you've got a creek and people are running four-wheelers through your creek and creating a lot of mud. Who controls that land that they're stirring up the mud? Who has ownership of that? Who has the legal authority to do something?
One person says federal. I'm going to say the landowner owns the land and the water's owned, the right of waterway, is that whatever, however you say it, is owned by the state.
The answer to the question is, it depends.
Well, that's not a good answer.
The problem that we have is in some cases, the land beneath the surface water is owned by the landowner, assuming they own both sides of the creek, of course, is owned by the landowner. But in many cases, it is controlled by the state, by TCEQ. And the difference between them goes all the way back to Spanish land grants and how people got the land grants at the time. I suppose the answer to this is see your lawyer, because it turns out to be a complicated question. One thing, and federal, by the way, does come into play here if it is considered navigable. And the definition of navigable isn't the same as the definition that I would think with my pontoon boat. The definition of navigable would include a kayak or a canoe or basically anything, which means pretty much any piece of water. So, and there's also an issue as to whether the water that we're talking about is connected to water outside of the property that it's on. So there are numerous questions that come up on this topic.
All right, so Ron, just to be clear, who owns the water and who owns the land under Lake Livingston?
The land under Lake Livingston is actually owned, or it's owned by the people, I guess. It's controlled by the state and managed by Trinity River Authority.
And who owns the water?
The water is owned by the people, managed by the state, and they've delegated the rights to the Trinity River Authority, which I'll talk about a little bit more in a minute.
Yeah, just to complicate this, when Ron and I do the Lake Livingston project, there's the city of Houston's is part of the discussion. The Texas Water Development Board is part of the discussion. The Trinity River Authority, the Corps of Engineers, Texas Parks and Wildlife. Who did I miss, Ron?
Did you say inland fisheries?
Oh, inland fisheries, that's Parks and Wildlife. Yeah, so there's like 6 organizations that all have different control under different aspects. And the Trinity River Authority, just so you know, goes from Fort Worth all the way to the Gulf of Mexico. So they control that whole stretch, and that includes all the packaged sewage plants and what you can put in that water and put out. And the dam. Yeah,
you're going to talk more about the TRA in a minute. There's a San Jacinto River Authority too over in your area.
Right, go for it.
The next question, and this is the last of them, and that is who owns the fish and the plants? I'll give you a clue. Look at question number 1. Once again, the fish and the plants are owned by the people, but it's managed and controlled by. Okay, you can answer my follow-up question.
The state?
By the state.
What part of the state?
Amarillo. What
They
part
don't
of,
know much about water up there unless it comes from the Ogallala.
so I don't know, what part of the state? TCEQ?
Fishing, the Parks and Wildlife.
Parks and Wildlife, Inland Fisheries Department.
Yeah, Parks and yes, the Parks and Wildlife control all of the aquatic fish and plants, and they have the ability to manage all of those in any way that they see fit. It's owned by the people and managed by Parks and Wildlife from authority from the state via legislation. Going on to the water management, there are, as Scott said, he named about 7 or 8. There's actually more like 100 entities that are involved in water management in Texas in one way or another, either directly or indirectly. There are various boards and whatever. What I've done here is I've listed 3 that I want to talk about, and I've included their number of employees because I was unable to find consistent financial information on these entities. I could probably get it through some sort of Open Documents Act or whatever. But if I take a look at the number of employees, I get an idea of what the budget looks like. The Texas Commission on Environmental Quality is the big guy with 2,800 employees, and I'll talk about their role in a second. They, for the most part on water, in our area, they've delegated their authority in what they do to the Trinity River Authority, which has 450 employees, and I'll talk about that more later. The San Jacinto River Authority is much, you know, I don't have a whole lot of data on them. The third one that's influential, and this has 400 employees, is the Texas Water Development Board. What I'm going to do is I'm going to deal with each one of these one at a time and talk about what they do. Going first to this is the Texas TCEQ, and they manage not only water, but also other environmental things such as air quality, as an example. But on the water side, they manage drinking water. They manage surface water rights. They're the ones that allow people to take water out of the water that the state manages. The water quality in the rivers and the estuaries, the management of wastewater and stormwater, and the management of groundwater and wells. Now, the management of groundwater and wells is somewhat legally limited, but to the extent that it can be managed, they do it mainly by monitoring and reporting and doing what they can to operate the bigger municipal and large industrial and the oil company fracking guys. In Montgomery County and Polk County and San Jacinto County and Walker County, the TCEQ has delegated almost all of this to the river authority that's involved, either the San Jacinto River Authority or the Trinity River Authority. So they do most of these things on a state level, and they gather up information on a state level, but the actual permitting and measuring and monitoring is done by the river authorities, which is my next slide. This one, the Trinity River Authority was the first one that was formed in the 50s, I believe. And it was formed because the Trinity River had become literally an open sewer downstream from Dallas. Dallas was polluting the crap out of it. We didn't get the Clean Waters Act at the federal level until the early 70s. But back in the 50s, the voters in Texas decided that the Trinity River needed to be cleaned up, and they formed this river authority primarily at the time to clean up the water. The river authority is a government entity, but it receives 0 tax dollars, nothing. They can, as a government entity, issue bonds, but they get almost all of their income from permit fees, either permit fees to take water out of the river or permit fees to return water to the river. And that's how they are funded. Scott and I have been dealing with them for some time. They're quite supportive. They've been very helpful to our project, and they're really good people. On the other hand, the planning is something that probably could be done a little better. They do strategic plans, they do tactical plans, but the actual implementation process has been a little slow. So it could probably be improved, but that's just an opinion, of course. I like those people. I think they've done a wonderful job of cleaning up the river. And when you look at the water quality in the river now versus what it must have been back in the 50s, it's amazing, absolutely amazing, the difference. To give you a feel for it, in Harris County, the average coliform count parts per million, the average parts per million of bodies of water in Harris County is around 1,400. Coliform is something that is a bacteria that comes from mammals, from the fecal release of mammals into water. And Lake Livingston typically runs under 10. So it's 140 times cleaner than the average body of water in Houston. Now, the funny part about it is you say, well, wait a minute, Houston has all kinds of sewage treatment plants and they charge an arm and a leg for water down there and for treatment. Why would there be such a high coliform count? The answer is when the coliform is analyzed, it turns out to be mostly from dogs, from dog poop flowing into the waters via the stormwater runoff. Interesting little tidbit, piece of trivia. The third one is the Texas Water Development Board. The Water Development Board is important in that they are a planning entity and they put together 50-year plans trying to make sure that there's sufficient development of water in Texas to support the growth of the state and the population and the industry and agriculture and the mining in the state. So they have a 50-year plan looking forward to try to come up with ways to make sure that there is sufficient water. The other thing that they do that's very important is they funnel grant money to water projects, to build these water projects that are going to create water supplies in the future. So they are a source of money. If I look at their 50-year plan, the last one that they did was in, what's the date on 2017. So we got another one coming up next year to do it every 5 years. If you take a look at their 50-year plan, they show that the major uses of water in Texas are irrigation and municipal. I'm going to go over my hour, Scott. Warning.
You're plenty good. I think I told Neil we'd sort of target 10-ish for rotating over.
Okay. The irrigation they showed going down, and that's not because we're going to have less agriculture. It's because agriculture has steadily been improving their irrigation techniques using drip irrigation rather than spray irrigation primarily. So the demand from agriculture is expected to go down because of conservation. Municipal is going up rapidly. And the reason for that is because of population growth, pure and simple. Manufacturing is relatively small and not a whole lot of change over 50 years. Steam and electric is smaller than that. Livestock and mining were smaller, but mining has gone up probably more than what this shows because of fracking. And fracking comes under mining, and fracking, for every barrel of oil that you pull out via fracking from the Permian Basin, you use 16 barrels of water to do it. And you create 16 barrels of wastewater that you have to dispose of, which is a big legal issue as well. Now, one of the things that I do want to point out on this, if you look at steam and electric and the use of water by steam and electric, much of the steam and electric is for cooling, the generation, the turbines. That water is just borrowed from the stream briefly and put right back in. So it doesn't disappear. Same goes for much of manufacturing. It doesn't take the water and remove it from the water cycle. Fact is, if you actually look at this, none of these activities permanently remove the water because of the water cycle. It may affect the timing of when the water is available, but it doesn't affect the total water resource. If I move quickly to surface water, this is just a quick note that twofold. Number one is there's only one natural lake in Texas, and that's Caddo Lake. And it's a natural lake only because of a natural dam that was formed by a log jam. All the other dams have been man-made, and they're all reservoirs. All of the major reservoirs, with the exception of Livingston, were built by the Corps of Engineers and have a flood control role and responsibility. Livingston was built and paid for 100% by the city of Houston. And the city of Houston owns the water rights and controls the water flows over the dam. And Scott's garage flooding is solely because of the city of Houston wanting to maintain the reservoir at a constant level. If I take a look at the water cycle once again, if I take a look at average precipitation, if you look at the state from east to west, the further east you go, the wetter it gets, the further west you go, the drier it gets. There it is. In East Texas, it's going up to 61 inches, and much of that area is right around 60 inches of rainfall a year. And it's contrast that with the Western Texas, which is less than 10 inches. So the water in the state is, surprise, 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 where the people are, or the people are where the water is, whichever way you want to look at it. And this has importance when we talk about future water, in that other parts of the state may be looking towards getting this water moved in their direction, like the Luce Bayou, for example, down in your neck. If I take a look at river basins, I'll quickly define the term. A river basin is everything within the boundaries that are shown there moves towards the river that eventually dumps into the Gulf of Mexico, or in this case, if we're looking at Trinity, the Trinity Bay. If you look at the river basins in the eastern part of the state, you can see that there's a lot of rainfall in the river basins in the eastern part of the state, and less rainfall in the river basins in the western part of the state. Also, if you look at the western part of the state, a lot of the river basins, the rivers originate outside of the state, where there are a few of them, like the Brazos, which is the biggest river basin wholly contained within the state, and Trinity being the second biggest. Speaking to something that Scott said earlier, what I've got here is one of the places that you can go to is the US Geodetic Survey, and you can get these kinds of graphs where they measure water flows at various points in the state. This data is available online. And I've superimposed two places. One of them is the water levels of the Trinity River at just above the lake, and the water levels in Goodrich just below the lake. And the red one, as you might guess, are the water levels above the lake, and the green one is the water levels below the lake. 2 points to take from this. One is that the lake is substantially moderating the flow of water. You know, it eliminates a lot of the short-term peaks downstream, but overall, the peaks upstream eventually get their way downstream as long as they last long enough to do that. You know, months. The other thing to look at here that's kind of interesting is, and I'd love to get the final information, I can't get it. We know that with a 85,000 acre lake that there's a fair amount of evaporation. And yet what I'm seeing is that consistently below the dam, I've got the same water that's flowing in to the lake at the source of the lake. So where is the evaporation coming from? And the answer is there are a whole lot of creeks that flow into the lake in addition to the Trinity River. It's not just a single river with a dam on it. What you've got is a river with a dam on it and dozens of creeks that feed into the water as well. And what happens apparently is that the creek flow pretty much balances out almost exactly the evaporation from the lake. So I've been looking for a study that would highlight this so I could see what kind of an impact we would have in clearing up the siltation in the creeks versus dealing with what's coming down the Trinity. This just basically says that the water level has been constant in the lake, and that's because we're in the higher eastern part of the state that has more water. If you look at the 50-year of the lake, by the way, the lake is supposed to have a 100-year life, and at 50 years, we're I think it was 14% silted in on average. So it looks like we're going to last more than 100 years as long as the siltation doesn't increase. Siltation, by the way, is not when the lake is such that you can drive your four-wheeler from Alaska to Point Blank. What it is when the silt reaches the bottom of the gates at the dam. That's when it's defined as the lake is no longer operational. So, and the dam is releasing water that's roughly 35 feet down. So roughly the water would still be 35 feet at the dam at the time when the lake reaches its full life. If you look at the 50 years of history here, you see that there are only 7 major periods of low water. And even then, it rarely got below, what is it, about 80% capacity. The big one there, the long one in 2006 is because the dam was severely damaged during Hurricane Rita and they had to rebuild the dam. The 2011 drought is a pretty deep spike, but it's not all that long lasting. We did not suffer from the drought nearly as long as other parts of the state. If I take a look at water that's available in the surface waters, either in the rivers or the lakes, you look at the Trinity River and it's by far the biggest source of surface water for the state of Texas. The Neches River, the Sabine River, the Brazos River are up there pretty high. The Rio Grande, although that's, I don't know, this might be older data than what I'd like. If you look, the San Jacinto is pretty puny down there. And you know, until they built Lake Livingston, the San Jacinto was the primary source of surface water for the city of Houston. And when we get to groundwater, I'll talk a little bit more about that, because the city of Houston was relying largely on groundwater. If I take a look at the watershed for the Trinity River, what I can see is that this watershed has all of the elements of land use. It's got urban areas, it's got rangeland, it's got agricultural, it's got forest land. As you can see, as it gets further south, so that these creeks that are flowing into our lake, for example, are coming from area that's largely forest land, which tends to create a whole lot of less siltation. One thing that's not shown on here that I wish it would have shown is that right across the middle of it, south of Corsicana, right in the Buffalo area, there are strip coal mines, massive strip coal mines going all the way across the watershed from one side to the other. And coal mines are potentially a huge source of water pollution. Although, as near as we can tell, we're not seeing any problems, because the management by the coal companies of the land has been fairly good so far. At least that's what the data shows. I worry about that a little bit, because if they start going bankrupt because coal becomes uneconomical, is there sufficient bonding to return the land to the state where it's not going to produce heavy metals and siltation downstream? Looking at another river basin, I'm over here looking at the Neches River basin. I'm showing this one because you see that the Neches River is coming down in the red and the green area, and the Angelina River, which is feeding into the Sam Rayburn Reservoir, is largely in the orange area. What's interesting about this is if I take a look at the land use changes in that eastern part of the state, only 23% of the land has been converted from its natural state into something else. In other words, there's man-made impact on 23% of the land there. Where if I look at the gray area upstream of us, you know, I've got one place where 75% of the land has been modified by man. And so there's a lot more of the impact of man in the Trinity River Basin, in the Neches River Basin, than in the Angelina River. And if you go to Google Earth, it's really kind of interesting. If you look at Google Earth above the Steinhagen Lake, above Dam B, watching the Angelina River and the Neches River come together, you see quite a bit of difference in the suspended solids in the water because of the of what is flowing into the water, what's involved. If I look at Lake Livingston, I see something interesting as well from the same Google Earth viewpoint. There is a causeway that goes across the middle of Lake Onalaska with a bridge at one end of it. And what's interesting to me is the difference in color in the higher siltation levels north of that causeway. So I think one of the reasons that the siltation levels are not so bad down in the bulkheaded part of the lake below the causeway is because the siltation is being settled out up by where Scott lives. And it's probably helping that causeway is probably going to extend the life of the lake in my theory. That's just my own personal theory. I haven't seen official scientific people come up with the estimates of that, but it's interesting on something that you can actually see in Google Earth. If I take a look at the land uses, I won't go into this too much, but coal is potentially a really bad one, but if it's managed properly, isn't too bad. Agriculture can be potentially a really bad one because of pesticides, because of silt runoff, because of fertilizers and phosphates, the conversion of land use. It also affects the absorption because the roots are shallow typically, so you don't get as much absorption down into the water table of the rainfall, and you get a lot more evapotranspiration, so you get less going into the groundwater. Silviculture is mostly done, well, I shouldn't say mostly, a lot of it is clear cutting. Clear cutting is bad, but on the other hand, tree farms grow trees back up, so it's a longer term type of cycle. There's nothing good to say about urban. Urban has a bad impact on just about everything involving water quantities and qualities. Flooding is caused by putting in concrete banks and channels and trying to move the water to the bayous as quickly as possible, which creates peaks and floods. There's just nothing good to be said. And you have a lot of concrete that is causing problems, not only because of the fact that the water doesn't flow into the water table, but I don't know if anybody knows, concrete is the second largest producer of carbon dioxide and has a impact on global warming, both from the reflection, the actual heat from the reflection at the ground level, but also the carbon dioxide that it produces in the greenhouse gases in effect. I live in the country. I'm going to skip this, Scott, because it takes a little bit of time. I'll just describe, you can go to TCEQ and they have monitoring points all over the state, and they publish this data. And you can get the data and create information relative to the test point that shows you what the water quality is in the various things that they're measuring. One of the reasons that I haven't been participating in Stream Team is there are 9 monitoring sites in Lake Livingston, so we can see the impact of what we're doing, which is what we were interested in, by looking at the monitoring sites, which are run by TCEQ and actually given to TRA to actually do the work. And TRA has a water quality lab, which is pretty sophisticated. And I kind of felt that the citizen scientist part was not going to be as effective, and I should spend my time in other things. I'm also, well, no, I'm going to do this one. We got time. Well, we don't have time. There's a very good video on groundwater. This is also on the TCEQ site that talks about groundwater and what is groundwater. But I'll give you my take here on a few things added to it. Aquifers are generally deep water that's well below the surface. We're not talking about the water table. We're talking about actual water that is constrained by clay or stone or something like that that creates a underground lake, sort of. But when I say lake, don't think of it as a lake. Think of it more as a sand sponge, where the water is contained in sand and well, primarily sand. And the flow of that water is not like it would be in a lake, where it would flow from up here where there's lots of water to down here where there's not much water as needed. That flow from here down to here might take a couple of 100 years. It will flow, but it's very, very slow. If I take a look at this one, which is the Edwards Aquifer, this is the one that people think of typically when they're thinking of aquifers. And here is a diagram of something of it where there are pockets of water underground constrained by limestone areas. And you've got drainage going into it, and you've got wells and springs pumping out of it. So you look at this and say, well, the water can flow from here down to here, down to here. It's all connected. The problem with that thinking is this is what it really looks like. those little pockets of water are tiny, and they're connected barely by cracks. And the water flow through the Edwards Aquifer, while is a lot greater than it would be on the Gulf Coast Aquifer, still tends to be relatively slow. And that's the point of water flow. If I take a look at the water table, which is an unconfined and therefore unnamed aquifer, if I move, it may take years and years to move from one part of the county to another part of the county, let alone to another part of the state. And, in some cases it will refill in days. In other cases, it takes years to refill. In the confined aquifer, refilling the confined aquifers may take centuries to refill it. And if you go further down to the lower levels of the aquifers, it might take millennia. So this is not like it's an underground lake that we can just tap into and the water will go to where it's needed. That's not the way it happens. It's a very slow movement. If I take a look at groundwater use by county in the state of Texas, very heavy usage up here in the Panhandle, and that's primarily farms that are pumping water out of the Ogallala, I'm sorry, I pronounced that wrong, water aquifer. And that's a problem because that aquifer is going down. They have to move into conservation. It's kind of interesting down here in the more urban areas, you see a whole lot less use of groundwater, and yet heavy use in areas where there is a lot of groundwater. The reason for that is because these people down here have treatment plants where they can take water from the surface water, where these people here are more dispersed and rely upon wells for their water. I mentioned the Ogallala. The Ogallala is a huge aquifer, and I'm going to mention it primarily because I'll contrast Texas and New Mexico and some of the other states as well. In Texas, as you recall, I mentioned to you that the landowner owns the water below the land. And Texas does not control it as long as the water stays on the land. If you start selling the water or shipping the water out, or if you're a really heavy user like a municipality, then the state may step in and actually have the ability to manage it under the way the laws are written. New Mexico, on the other hand, controls all of the groundwater just like it does the surface water. You have groundwater rights that you have to get and use. And those are controlled by the state. Kansas, if you go up there, it's similar to Texas, except that it specifically says that the water is owned by the state and the state gives water rights, but the exception to that is water that's taken for household use. And included in household use are small farms. Once again, you start getting into complicated legal distinctions as to what is household use, et cetera. The legal issues of groundwater can be pretty complex and tangled. I won't go into this other than to show that this is the Water Development Board is saying that the water aquifers are generally going down over the 50 years and will be less available for use to meet the water needs. This is an example of the aquifers showing that they're not a flat area that's below the surface that is 1,000 feet down everywhere you look. They go down different distances, and many of them once you get to a certain point become salty. They become saline and not drinkable directly from the aquifer if you were to pump into it. In other cases, the aquifer actually makes it up in a relatively small area to the close to the surface. I was saying I was going to talk about Houston. Houston used to rely upon wells, and they found this doesn't show the maximum, but at one point there were places that were 16 feet had sunk down because the water had pumped out of below the surface and the land had sunk down. As the water was pumped out, the land sank down. And then the Galveston Bay started to cover up entire parts of the city because it sunk below sea level. So back when the dams were built, it was to deal with this problem, because otherwise ultimately potentially the whole city of Houston would have been underwater because of the groundwater pumping. So they had to do something to reduce the dependence on groundwater. If I take a look, and this is the second to the last slide, Scott. If I take a look at the need for the future, theoretically, we could do new reservoirs, but reservoirs are not a very efficient way of doing it. Number one, they subject the water to a fair amount of evaporation. Number two, you have to get the land, and it's very expensive to get the land and very expensive to build the dam. When Houston built Livingston Dam in the 1969, they spent $74 million, and you know I'm guessing now that we'd be looking at billions. These are on the books. There are a whole bunch of reservoirs that are on the books and planned. There are plans to build reservoirs, but there haven't been any major reservoirs built since the 90s. So this is something that just generally doesn't look like it's a future source of having water. Aquifer replenish is important in the middle of the state, and that's something that they're doing in the Edwards Aquifer and for San Antonio and Austin. This is a critical step that they're taking to try to get more water into the aquifer and less of it evaporating or running off over time. Conservation, obviously very important for agriculture. I've already talked about it. You can do it in the cities. The book that I mentioned at the beginning, The Big Thirst, reuse of gray water for irrigation is one of the key things that they did, using orange pipes rather than black pipes or white pipes that would signify potable water. Orange pipes means that it's gray water, still good for irrigation, but you probably wouldn't want to drink it. Technology is the most effective, or not the most effective, one of the techniques, and by that I generally mean desalinization. Desalinization involves using reverse osmosis. Reverse osmosis has two problems. One is it requires a lot of energy to do it. So we're converting energy into water via the RO process. It also, for every gallon of clean water, you waste at least a couple of gallons under current technology of water that is washed away to clear out basically clear the filter. So technology is going to be a function of the cost of energy. And it probably is going to be a function of how we start charging for water, or if we start charging for water, something that we haven't done yet. Regional reroute has been happening for a while. The Luce Bayou is an example of rerouting water from the Trinity River to the San Jacinto watershed to provide more water over in that one. There's more of this up in the northern part of the state, where water is being routed west to Dallas and Fort Worth from various places east via canals and pipelines. This is an infrastructure kind of a project and is much less costly than a reservoir, and solves the problem directly of moving water from where it's plentiful to where it's gone away. And lastly, and that is the recovery and reuse of water, both at a local level, an individual level, a personal level, property level, and also at a citywide, countywide, statewide basis. Just a little bit of trivia, and I've heard various numbers on this, but if you take a molecule of water that falls from the sky and falls into the Trinity River up northwest of Fort Worth and starts heading downstream. By the time it gets to the Gulf of Mexico, it has left the river and returned to the river somewhere between 7 and 19 times. That we already have a lot of reuse and recovery going on, but there are opportunities for doing it and doing it smarter and doing it better. Keeping in mind, by the way, that there is a fair amount of water that flows out of the state, and there is a fair amount of water, in fact, is the vast majority of water that just evaporates back up into the sky and moves with the clouds and floods people in Ohio. So that's the end of it, Scott. I can take questions for a while if you want to, or you can just go ahead and
Maybe not for a while. Why don't we open it up for like 1 or 2 questions before we take a quick break and get Neil started. Anybody have a question here? Anybody have a question online?
I have a comment from online from Terry.
Okay,
She stated that Nevada just passed a new law that bans non-productive turf grass, such as lawn expanses at neighborhood entries to save water, which I think is a great idea.
yeah, just here's a further to that. Here's 2 anecdotal things, and then I want to give a plug out to Terry real quick. The Texas A&M, I built a new house up in southern Walker County. The Texas A&M Forest Service guys from this office actually came out to the property and looked around, and it's a forest. And they said, so what kind of, do you have to put grass down? So, well, they're going to require some sod around the house for erosion. And they said, whatever you do, don't do St. Augustine. So, because it takes a lot of water, it's sensitive to heat, it gets lots of diseases and fungus and blah, blah, blah. And they told me, so Texas A&M engineered a type of zoysia called Palisade. This is anecdotal, so somebody's got better information, correct me. It uses less water, it's disease resistant, it's drought tolerant. We get droughts all the time, right? 2011, the huge drought here. So I used to have a house in West Houston. I spent my life watering that damn yard and putting chemicals all over that yard, and I don't do that anymore. This grass was supposedly engineered, even though zoysia's been around, this specific type was engineered for South Texas to help get control over the amount of water that we use to put back on our yards, to reduce the amount of water consumption. So here's where a plug goes in for Terry. Terry MacArthur is one of our resources for water. She's a certified stream team educator. She's given many of us here education on that, where you can get kits from the state. You can do monitor water quality as part of your volunteer hours. She is one of our resources that we look to for Texas Waters, for water information. She's part of the Woodlands Environmental Township. So the Woodlands, interestingly, and we're going to hear a lot of issues about Montgomery County coming up in the next presentation. So you've got all these nice discussions going on in the Woodlands about how to do water conservation. In the city of Houston, do you know how much water conservation they advocate? Zero. So last I looked, there's 5.5 million people in this area. There's more moving here all the time. There's only, as Ron says, there's a limited amount of water, period. And that's why, you know, he and I get involved in the Trinity River and the Lake Livingston stuff, and it's a lot of fun, but it's a critical resource for a city of 5.5 million people that's trying to get off of groundwater. And so subsidence is a big issue. We talked about that a little bit in the geology presentation. So, and Terry says, if you see on the screen, zoysia is a better choice for our area, not a native grass, but uses far less water. That's why they engineered it. And I can tell you, I put it down at my house several months ago, and I just ignore it and nothing happens to it, but it's great stuff. But anyway, Terry is one of the people that you should reach out to. And when you see her advertised through the bulletin that she's going to have water discussions, watershed and all that stuff, you ought to give it a shot. It's a lot of fun.
I'm replacing my grass with button bushes.
Yeah, you live on the lake. You're one of those rich people with too much water that don't flood. Let's see. Neil, are you still with us?
Yes, I'm here.
Do you, I don't know how long you'd like to go, Neil. Do you have time for everybody to take a restroom break for just a few minutes?
That would be a requirement, I would think.
All right, so Neil, I've got 10:02. How about if we try 10:10? Would that be okay with you?
That'll work.
Okay, and has somebody already given you control over the screen?
I have no control as far as I can tell.
Well, let me find you on my chat room. Lisa, Linda, I'm trying to find you. Let me find you. There's too many people on this thing, Neil. There you are. I'm going to make you a co-host. You are now a co-host. By the way, Ron, thank you, Ron. I appreciate the effort and great stuff as always. Okay. We'll give him a few minutes before we start, Neil, but you've got control now as a co-host, and you can just share your screen whenever you feel up to it, okay?
Okay, thanks.
I'm going to
Scott.
stay on, Scott, to listen to Neil.
Absolutely.